Collier, and today we're doing scientific notation and absolute value. Now, scientific notation is also called standard form in the UK. It's very useful for writing very small and large numbers, like in science. That's why it's called scientific notation. Okay, so the number of people in the world, this might not be current, but this is about 7,850,000,000. And you can write that as 7.85 times 10 to the power of 9. Okay, so because this is 9 decimal places up to the 7.85. So the idea is you always have a number between 1 and 10 here. And here you have a power of 10. So you can instantaneously see how large the number is. Okay, like a virus is very tiny, so it's much less than a meter. This is 7 decimal places to go here, so it's 1 times 10 to the power negative 7. Okay, let's look at some examples. Well, here's some examples you can read yourself. This is 5 decimal places, so it's 3.45 times 10 to the power 5. This is 4 decimal places to get after the first non-zero digit, which is 3. So that's 4 decimal places, and it's a smaller number, so it's times 10 to the power of negative 4. Okay, that's because that's the same as dividing by 10 to the power of 4, which is 10,000, and it makes this very small number right here. Okay, so let's take a look. Thickness of a piece of paper is this many meters. So you just need to count the decimal places. 1, 2, 3, 4, 5. So it's 6 times 10 to the power of 5 meters. That's all but the decimal places. 3, 6, 9, 12. 9.46 times 10 to the power of 12 kilometers. Okay, write the following as ordinary numbers, so going from scientific notation backwards. That's just, you take 1 and multiply by 10 to the power of 7, you're going to have a 1 with 7 zeros, so that's 10 million. And this is, you start with 7 and you're moving 7 decimal places this way. 1, 2, well, you see, just move 1 here, then you're going to have 6 zeros, so it's going to be 1, 2, 3, 4, 5, 6, 7, that's 7 decimal places. Okay, you can do some calculations without a calculator. If you have the same exponent, you can just subtract them. Okay, so this is times 10 to the power of 13. So you can write it like this, right? That converts it to 10 to the power of 12. You just factor out 110, and then you get 13 times 10 to the power of 12 minus 4 times 10 to the power of 12. This is just like 13x minus 4x is 9x, and you get 9 times 10 to the power of 12. Okay, next one. You apply the exponent to everything in the brackets, and you get 125 times 10 to the power of 42. But this is not in scientific notation. This number needs to be between 1 and 10. So we need to move the decimal 2 places. Okay, we're making this number smaller, then this one becomes bigger. Okay, it's kind of like you're doing 125 times 10 to the negative 2 times 10 to the 44. This becomes 1.25. Again, we want the same exponent. We can say 79 times 10 to the power of 14 plus 2 times 10 to the 14, all under a square root sign, and then we can add them together. 81 times 10 to the 14. We can square root 81, and we can square root 10 to the 14, and we get this. Same procedure here. Okay, we can bring this down to 12, and we have 3 times 10 to the 12 plus 4.1 times, actually, I'm going to convert that to 12. It's going to be 41 times 10 to the 12 over 4 times 10 to the negative 5. Okay, we add it together. We get 44 times 10 to the 12 over 4 times 10 to the negative 5. So dividing, 44 divided by 4 is 11. And when you divide, you subtract the exponents. So this is going to be 10 to the power of 7. Okay, a couple of word problem examples. Here we have H2O. Find the mass of hydrogen peroxide. Actually, and two atoms of, so it's not H2O, this is H2O2, is hydrogen peroxide. H2O is water, so it's slightly different. But we want to get the mass of one molecule of peroxide. We do 2 times 2 hydrogens plus 2 oxygen atoms. Okay, and then we add them together. So let's multiply these together. This is going to be 3.32. If you multiply this, you get 3.32 times 10 to the power negative 24. And you multiply this, you get 5.32 times 10 to the negative 23. We want these to be the same. So actually, we could make this one smaller maybe. If we make this exponent smaller, this becomes bigger. Okay, remember smaller is like that, right? Okay, now we can add them together and we get 56.52 times 10 to the negative 24. Maybe I should have made them both 23 and I get the answer right away, because this needs to move one decimal place. So it's 5.652. This became smaller, then this must be bigger. And we get, this is the mass of one hydrogen peroxide molecule. So you do this kind of stuff in chemistry all the time. Okay, a pack of seeds weighs 50 grams. A gardener finds that a packet of 30 seeds, the weight is this. So if you do 50 divided by 6 times 10 to the negative 2, that's the weight or the mass of one packet. So if you want to get how many seeds there are in a bag of 50, we need to multiply this by 30. Okay, so this is just 0.06. And the best way to handle this is to multiply numerator and denominator by 100. So we just get a 6 on the bottom. So it's 50 times 30 times 100 over 6. And 30 divided by 6 is 5. So this is 25,000 seeds. Okay, next, absolute value. Absolute value is graphically defined as the distance away from 0. So you can see this distance away from 0 is 3. This distance is 3, okay? But that's negative 3, and this is positive 3, so this is the symbol. Absolute value negative 3 equals 3. Absolute value of 3 equals 3. This is the distance away from 0. Okay. Another way to think of it is absolute value always makes your returns a positive answer when you do it. Okay, so this is the absolute value symbol. You add these together, you get 20. And 20 is 20 away from 0, so it's just negative 20. Okay, but in the second one, you got negative 60. So when the absolute value negative number is just positive, because negative 60 is 60 away from 0. And here, let's do that first. That's 10, so that's negative 10. And the absolute value of negative 10 is 10. So you got negative 14 plus 20 equals 6. Now these are a bit tricky because absolute value depends on whether the value is positive or negative, right? So we know pi is about 3.14. So 4 minus pi is a positive number. So this is just not going to change. It's 4 minus pi, right? I guess it's 0.86 about that. If you look closely at this one, root 3 is bigger than 1, so you got a negative number in here, right? And when you get a negative number, it becomes positive. Okay, another way to make a number positive is to multiply it by negative 1. Okay, if you take negative 60 and multiply it by negative 1, you get 60, so it's the same thing as absolute value. So that's what we do here. The absolute value of this, because it's a negative number, is like negative 1 times this. So it's actually negative 1 plus root 3 over 2.